Alright guys, today we're going to start off with a quick little review of how to solve inequalities. So on number 1 we have 2x plus 6 is greater than 12. We're just going to solve like normal, so subtract 6 from each side. And I get 2x is greater than 6. Divide each term by 2. And I'm left with x is greater than 3. Then to graph it, since there's only one inequality, we don't need helper graphs. We can graph it straight on the line. That's going to be an open dot on 3. And my arrow is going to go to the right. Now to write that answer in set builder notation, we'll have this set of all x's such that x is greater than 3. On number 2, we can solve for x by adding 3 to each side, and we'll be left with 1/2 x is less than or equal to 3. Multiply each side by 2, and x is less than or equal to 6. So again, we can graph it straight on my graph. That's going to be a closed dot on 6 and an arrow going to the left. And then we'll have this set of all x's such that x is less than or equal to 6. On number 3 to solve, we're going to subtract 3 from each side. And we'll be left with negative 1/3 x is greater than or equal to negative 1. Multiply each side by negative 3, and these will cancel out and leave me with x. Negative 1 times negative 3 is a positive 3, and since I multiplied by a negative, my symbol switches, and now it's less than or equal to. So on my number line, that'll be a closed dot on 3 with an arrow going to the left. Then we'll have this set of all x's such that x is less than or equal to 3. So I want you to take note on number 1, 2, and 3. We only have one variable in each one of these problems, and our number line is nice and flat. It's one-dimensional. It goes left to right. Now, if we look at this example here, we're going to talk about what happens when we have two variables, an x and a y. Now, instead of a number line, we have a coordinate grid because we have left to right and up and down. So our graphing inequalities when there are two variables is a lot like graphing inequalities with one variable when it comes to open dot, closed dot. If you have a symbol that is less than or greater than, instead of doing an open dot, what we're going to have is a dashed line. And then when you have less than or equal to or greater than or equal to, instead of a closed dot, we're going to have a solid line. Now, when it comes to actually graphing the inequalities, it's a lot like graphing regular equations. So we have y is greater than 3x minus 4. So I want to start at the y-intercept of negative 4. So here's my pin on the origin. To find the y-intercept, I go down 4 and put a point. And then I have a slope of 3. Now remember, that was 3 over 1 and rise over run, so I can go up 3 to the right 1, up 3 to the right 1, and up 3 to the right 1. Now, remember, you have to have 4 points on your graph, and next we want to connect it. Now, to figure out if it's solid or dashed, you need to look at the inequality symbol. Since it is greater than, not greater than or equal to, that means we want a dashed line. So I'm going to connect that with my straight edge as a dashed line all the way through my graph and have arrows on the end. Now, when you're graphing with one inequality, notice that you have an arrow shading one direction or the other on the number line. The same thing's going to happen when we have graphs on a graph. We want shading to say which way is going to be the correct answer. So to think about this, I'm going to pick an ordered pair. I'm going to pick any ordered pair that I want. For example, I'm going to start with this ordered pair right here. This ordered pair is 9, 3. I want to substitute this ordered pair over here into my equation to see if it's true. So I'd substitute 3 in for y because it's x, y. So I'm going to substitute 3 in for y, and that's going to be greater than 3 times 9 minus 4. Now let's see if we simplify this, if it works. So 3 times 9 is 27. 27 minus 4 is 23. And I want to say, is 3 greater than 23, and it's not. That's not a true statement. So that means any ordered pair that I choose over here on this side of my line is not going to work. It's not going to make it a true statement. Now let's see if I pick a number over here on this side of the number line if it's going to work. So the easiest number over here on this side is going to be this dude right here, that 0, 0. So let's see what happens when I substitute that in. So if I substitute x, y, I'm going to substitute 0 in for y and 0 in for x. So that's going to be 0 is greater than 0 minus 4, and 0 is greater than negative 4. Now this is a true statement. 0 is greater than negative 4. So that means this ordered pair works. It makes it true, which means every ordered pair on the same side is also going to work. So I want to shade all of the area over here to show that any ordered pair that I pick is going to work. So make sure you don't cross the line, but you just need to lightly shade. You don't have to overkill. Just lightly shade to show that all the points on this side of our line will make it a true statement. Now with this specific inequality, if I were to choose a number on the line, it would not work because it is a dashed line. Since it is greater than, it would not work. Now be careful if you're shading and you accidentally cross the line, you need to fix it. You need to erase it so it does not cross the line. Let's try it again. On number 5, I have x is greater than 4. Now be careful, when we have one variable, that means it either has to be a horizontal or a vertical line. So with the variable being x, that means we have a vertical line, so it goes straight up and down through 4. So straight up and down through 4. Here's 4. And I'm going to get my straight edge, and I want it to be a vertical line, so straight up and down, but it's greater than, not greater than or equal to, so it's going to be a dashed line. So let's draw a dashed line through 4. Now to figure out what side to shade on, we need to look at the x values, because I want my x values to be bigger than 4. Well, here is my x-axis, and if I'm following my x-axis, here's 4. If I'm going to the left, it goes 3, 2, 1, 0. Notice the numbers are getting smaller as I go to the left. So smaller than or less than would be on the left side, but I don't want that. I want greater than. So if I go to the right side, 5, 6, 7, 8, those are all of my greater than numbers. So I'm going to shade on this side. On number 6, we have y is greater than 1/2 x minus 3. So let's start with the y-intercept of negative 3. So if my pin's on the origin, to start on my y-axis at negative 3, I'm going to go down 3 and put a point. And my slope is 1/2, so that's rise over run. I'm going to go up 1 to the right 2. So up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Next, we need to connect it with a straight edge, but since it is greater than, not greater than or equal to, we need to use a dashed line. So I'm going to connect it with a dashed line all the way through the graph and end it with arrows. Now, if we look back at that example that we had, when the numbers were greater than, when that was the symbol that we were working with, we ended up shading above the line. So here's what I want you to do. We're going to make this very, very simple. Every time that you have a graph that we need to shade, I want you to pick the easiest point on our graph, which in this case is 0, 0. That's always the easiest point. We're going to substitute it in to see if it works. So I'm always going to put a 0 in for y and a 0 in for x. So 0 is greater than 0 minus 3, 0 is greater than negative 3. If it's true, if it works, we're going to shade on the same side as that. So on number 6, it definitely works, so I want to shade above my line. Now remember, do not cross your line. We want to shade on the same side as that 0, 0. Let's try to get on number 7. So number 7, I have y is less than or equal to negative 3. So if it's less than or equal to, we have a one variable, and it's horizontal line, so it's going to go left to right through negative 3. So I'm going to put a point at negative 3. Now, if you'll notice, this is less than or equal to, so this line is actually going to be a solid line. Now, when it is a vertical or horizontal line, it's really hard to substitute an ordered pair in. Like if I wanted to substitute in 0, 0, I could only substitute in the 0. So for example, this is 0, 0. Sorry, my pen's big now. And I would only be able to substitute in the 0 for y. So that would be 0 is less than or equal to negative 3, which is not true, so I can't shade on that side. Now another way that we could look at it is less than or equal to would be below my line. So let's shade below. Alright, on number 8, we have y is less than 2/3 x. Now, there's nothing added to the end here, so that means my y-intercept is 0. And then I have a slope of 2/3, so rise over run, up 2 to the right 3, up 2 to the right 3, up 2 to the right 3. And since it's less than, that means it's going to be a dashed line all the way through, end it with arrows. Then we're going to pick the ordered pair 0, 0 to see if it works. But that's not helpful because the line is actually on 0, 0. So instead, we have to pick a different ordered pair. I'm going to pick this ordered pair right here, 2, 4. Let's substitute that in and see if that works. So I'm going to substitute the 4 in for y, and I'm going to substitute the 2 in for x. Now 2/3 times 2 over 1 is going to give me 4/3. Now 4/3, if you put that into your calculator, is approximately 1.3. So they're saying 4 is smaller than 1.3, which is not true. So I'm not going to shade on the same side as that guy. So that means I'm going to shade below my line. Now another way to look at this is you can look at the symbol and figure out which way to shade. So if you have less than or equal to, you want to shade below the line. So this one is less than, I'm shading below the line that I drew. If you have greater than or equal to, you want to shade above the line that you drew. So on number 8, it was less than, and we ended up shading below. On number 7, it was less than, we shaded below. Let's look at number 9. On number 9, I have y is greater than 2x plus 1. So my y-intercept is at a positive 1, and then I have a slope of 2. So rise 2, run 1, rise 2, run 1, rise 2, run 1. And I have a greater than, there's no equal bar, so it's going to be a dashed line all the way through, end it with arrows. And now let's go back to look at if I chose the ordered pair 0, 0, would this be true or not? So if I put a 0 in for y and a 0 in for x, does this work? So 2 times 0 is 0. 0 plus 2 is 2. Is 0 greater than 2? It's not. So I don't want to shade on that same side. I want to shade on the other side of the line. Now, if we look at the symbol, let's see if it still works out to what we talked about on the last problem. If it's greater than or equal to, we shade above. Less than or equal to, we shade below. Well, this was a greater than symbol, so I wanted to shade above the line. And if you look, it kind of looks like that line is holding up the shading, so we are okay. On number 10, notice we can't graph until we solve that guy for y. So let's start off by solving for y. So we're going to divide each term by -2. These will cancel out and leave me with y. I divided by a negative, so my symbol has to switch to a less than or equal to. And then 4x divided by -2 is -2x. And 10 divided by 2 is -5. Now to graph, we look at only this guy right here. I don't care about this guy over here anymore. I'm done with him. Let's focus on this guy. So I'm going to have -5 is my y-intercept. And then negative 2 is my slope. So that is a negative 2 over positive 1. That's going to be down 2 to the right 1, down 2 to the right 1. I can't go anymore, so I'm going to go up to the y-intercept and go up 2 to the left 1. Now I want to connect. Now notice it's a less than or equal to symbol, so it's going to be a solid line all the way through. And I want to shade. Let's see if we can figure out where to shade now without substituting in an ordered pair. Now this says it is less than or equal to. So less than or equal to means I want to shade below my line. So if you look, on one side it looks like the line is holding up the graph, and on the other side it kind of looks like the line is pushing down the graph. So here's where it's pushing down. This is below the graph. And again, you can always check that by picking the ordered pair of 0, 0. So if I pick the ordered pair of 0, 0, notice it's not on the same side as the shading. So if I substitute it in, it shouldn't work. It should be 0 less than or equal to negative 2 times 0 minus 5. 0 less than or equal to 0 minus 5. Is 0 less than or equal to negative 5? It's not, so we're right. On number 11, we want to solve this guy for y. So go ahead and pause the video and solve number 11 for y. So when you solve for y, you should get y is less than 3/4 x minus 3. So now we're done with this guy. We don't care about this guy over here. We only want to focus on graphing this guy. So I'm going to start with negative 3 on the y-axis, and I have a slope of 3/4. So up 3 to the right 4, up 3 to the right 4, and I can't go anymore, so I'll go back to my original starting point and go down 3 to the left 4. Now I want to connect with my straight edge. So since this is not or equal to, we're going to have a dashed line. And then we want to look at the symbol. This is less than, so I want to shade below my line. Number 12. Again, go ahead and pause the video and solve for number 12. When you solve, you should get y is greater than or equal to negative 3x plus 2. So I'm going to start at 2 on the y-axis, and I have a slope of negative 3. So I'm going to go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. This is a greater than or equal to, so it's going to be a solid line. So if I connect that guy with my straight edge all the way through, then it's greater than or equal to, so I want to shade above the line. Now again, if you're having trouble figuring out, well, I don't know where above the line is, pick that easy ordered pair of 0, 0 and see if it works. So 0 greater than or equal to negative 3 times 0 plus 2. That would be 0 plus 2. And 0 greater than or equal to 2. Now 0 is not bigger than 2, so I don't want to shade on that side with the 0, 0. I want to shade on the other side. Now, on the next problems, they're giving us graphs and they want us to write the inequalities. So we're going to treat this just like writing the equation of a line. However, instead of writing an equal sign, we're going to save the inequality sign for last. So if you'll notice, on number 13, we have a vertical line straight up and down, which means we're only going to be dealing with the variable of x. Now, let's look at the number that it goes through. So here's 1, 2, 3. It goes through 4 on my x-axis. So that's the number we're going to be dealing with. Now let's look at where they shaded. They shaded where the x values are bigger than 4. So that means we have two options. We can either be dealing with greater than or equal to. But since this is a dashed line, that means it's going to be greater than. On number 14, let's look at the slope and the y-intercept. So this is going to be in y equals mx plus b form, where m is our slope and b is our y-intercept. I'm going to start by writing down my y. I'm going to leave a little space, skip a little space for the inequality symbol. Now I'm going to look at the slope. So I can count the slope from one point to the next. I can go up 2 to the right 3, up 2 to the right 3, up 2 to the right 3, that means my slope is going to be 2/3. Then I can tack on my x. Then I want to add my y-intercept where it intersects with my y-axis. So it crosses my y-axis right here at 4, so that's going to be +4. Now, if we check out where this graph is shaded at, it's being shaded above my line. It looks like my line is holding it up. So that means it's either going to be greater than or equal to. But since my line is solid, that means we're going to have a greater than or equal to. Let's try it again on number 15. On number 15, we're going to start with a y, leave a space for the inequality symbol. Now we're going to look at the slope. So let's count the slope from one point to the next. I'm going to go up 1, 2, 3, 4, right 1, up 4, right 1, up 4, right 1. That means my slope is going to be 4/1, which is just 4. Then I want to add my y-intercept. So my line crosses right on the y-axis at 0, which means I could add 0, but that really doesn't help me much, so I'm just going to leave it off. Now to figure out what my symbol is, let's look at how they shaded. Now they're shading below the line. Notice how my line is kind of holding this graph down. So that means I can either use less than or equal to. And since it's a solid line, I want less than or equal to. Finally, go ahead and pause the video and do number 16 on your own. Alright, hopefully you notice that we start with a y, and then we have a slope of -1, 2, 3, 1, 2, 3, 4, 5, -3/5. And then we intersected the y-axis at -8, so -8. And then it's less than because it's shaded below with a dashed line.